In this video, we will learn about the solutions regarding the quiz that we have done in the previous class or for previous assignment. So starting with this question, if opcode is equal to RESW, then from these options, from answer is add 3* hash operand to the LOC CTR value. So this answer you will be getting from the algorithm. Here from this algorithm you will be getting these details like if an opcode is found, then add 3 to the LOC CTR value, and if the opcode other than the opcode in the optab field or optab data structure, if the opcode value is word, okay, if the opcode value is word, add 3 to LOC CTR value. If opcode is equal to RESW, then add 3 into hash operand to the LOC CTR. And then if opcode is equal to RESB, add the operand value to the LOC CTR. That is, reserved byte means number of bytes that will be loaded, added to the LOC CTR. And if opcode is equal to byte, then you need to find the length of the constant in the form of bytes, length of the constant in bytes, and add that length to the LOC CTR value. If the opcode doesn't belong to optab and some of the opcodes that is listed in the algorithm, then it will be showing the error. This is related to the opcodes that is encountered in any assembly language program. So based on that, the first some questions are there like if RESW, then add 3 into hash operand to the LOC CTR. This hash operand means some value, reserve word, some constant value will be given. So it will be in the form of digits. A reserve word 5 means 3 into 5, 15 will be added to the LOC CTR value. Then if opcode is equal to word, then you need to add 3 to the LOC CTR, which means that one word is equal to 3 bytes. Add 3 to LOC CTR. And if opcode is equal to byte, then add length of bytes to the LOC CTR byte, and it will be mentioning some list of characters in the operand field. So the length of the bytes that represents the character you need to mention. Then if the opcode is equal to RESB, then add hash operand to the LOC CTR value, which means you need to reserve byte 5. So that 5 bytes will be added to the LOC CTR value. If symbol is not found in the SymTab, then it will be inserting symbol name comma null. Okay, if we are searching for some symbols in the SymTab, and if the symbol is not found, then means that you need to make a new entry into the SymTab. So a new entry will be given like insert symbol name comma null. And if symbol is found in these things, you will be getting from the algorithm itself. If symbol is found in SymTab but value equals null, then insert the LOC CTR address to the end of the linked list, which means that it is not defined and it will be defined elsewhere in the program. So the current LOC CTR value will be inserted into the linked list, so that when the symbol is encountered elsewhere in the program, its address will be updated in the symbol table, and once it is updated in the symbol table, it will be checking the list of pointers where the change need to be reflected, and to those pointers also you will be getting that pointers means it will be managed in the form of linked list. From that, address will be taken, and the new address that is being assigned to the label will be updated in those addresses, which means in those addresses the symbol is being used which need to be updated. Then if symbol found in SymTab and value not equals null, which means there exists some value, then insert the symbol value as the operand address. Directly you will be inserting the symbol value as the operand address. Then symbol used to identify the literals, equal symbol will be used. So these are some examples in which we will be making use of this equals. Then what is the difference between using CEOF and X05? So it means that one is the end of file string character and one indicates the integer value. So in case of EOF, when it is generated, an object code is being generated, the ASCII equivalent will be taken and will be displayed. It represents the string, character string constant. And in case of X05, so this object code, what it will be generating, it will be generating a 05 as the object code, and it represents an integer value or hexa value. Then assembler directive used, which is used to place literals into a pool, that is LTORG. Literal, it will be placing the literals into the pool, making use of the directive LTORG. So once LTORG is encountered, all the literals will be placed in a separate pool. Then what is the object code generated for the following code fragment? Opcode WD opcode for WD will be DC. LTORG, this is the directive for literals, and it will be having a statement starting the address will be 106B WD, write data, and this will be the operand field equals X05. So WD, opcode of WD is said to be as DC, and X05, the operand field, this is a input device, and that is defined in the instruction 1076. So here this star indicates the label, okay, and equal to X05, it is specified in the operand field. So once this is being executed, how the assembler generates the object code? If W, so we can see like this. So in this case, consider the statement LTORG. Consider the statement next to the LTORG, that is 106B WD X05 is equal to X05. So in this case, WD DC. So D will be taking the value as, what is the value? 13. So D will be having the value 13. And C will be having the value as 12. So when you are generating the object code, you will be taking the format opcode, opcode with 6 bits, followed with NIX BPE, then the displacement field if it is following a format 3 instruction. Okay, 3-byte instructions. So opcode for 13 DC, 13 will be like 101, and for C 12 it will be 1100, and here opcode it will be mentioned using only 6 bits, so the later 00 will be removed. Okay, then NIX BP, NIX simple addressing mode, so 11. X, no index addressing mode is there, 0. Base relative addressing not used. Program counter 1. E is, since it is a format 3 instruction, it will be 0. And now you need to calculate the displacement field. So how the displacement field can be calculated? Based on the operand value. So here the operand value is X05, which is defined in the address 1076. So 1076 is the target address, and currently while executing this 106B, the address of the instruction will be, the PC will be updated with the next address instruction, which means WD is equal to WD, that instruction, it will be taking a 3-byte instruction. So 106B plus 106B plus 3 will be equal to 106C. 106C. So that is the current PC value. So 106E will be subtracted from the 1076 to get what is the value you will be getting. So here 6 minus E. So E is 14. So you need to borrow the value from here. So 7 will become 6 and here 16. 16 will be, since it is a hexadecimal hexadecimal subtraction. So 16 plus 6. 16 will be borrowed from left hand side. 16 plus 6, 22. Then 22 minus E. You will be getting the result as 22 minus E. E is 14. 22 minus E will be 8. So you will be finally getting the result as 008. Okay. So placing that 008 in the displacement field, your format will be like this. Now what you need to do, you need to combine the statements, that is bits. First 1101, then 1111, 0010, then 008. So resulting in, what is the object code that will be generated? 1101, 12, 13. So 12, 13 means it will be, so first 1101 will be 13, that is D. D. Then D, then 1111 F, that is 16F, 15 F, then 0010. 0010 you will be getting 2, then followed with the displacement field 0008. 008. So this is the object code that is generated for this statement. So DF 2008. Okay. Then next, assembler directives used to define the symbols and specify the value. EQ and ORG are the directives used. Then data structure used to handle literals, lit tab, or you can lit tab, that is the data structure used. Okay. Then data structure used to track whether the symbols are relative or absolute, it is SymTab. Answer is SymTab. You need to data structure എന്ന് പറയുമ്പോൾ the SymTab terms വേണം use ചെയ്യാനായിട്ട് SymTab. So symbol table, if it is given as an alternate solution. Then absolute and relative expressions. So in case of absolute expressions, the absolute value or the constant will be returned as a result. Okay, so if the result of the expression is an absolute value or constant, then we can say that the expression is absolute. And in case of relative expression, if the result it is relative to the beginning of the program, then it can be considered as a relative expression. Then directive that is used to indicate the different blocks, we make use of use directive. If use is not used, then it will be considered to be as a default block. Then next one is related to the object code that is generated. Here in this case, you use so these instructions, it will be coming together. 0000 first STL RET ADR. Okay, so you need to find out the object code for the instruction. So in this case, first STL is given as 14. So C data is the control section, data section, and ret address is defined in that C data section. So in order to write the starting to write the code as object code, STL 14 0001 0100, then so last 2 bits will not be used because 6 bits. Then NX BP N simple addressing mode X0 B P So after assigning the bit values for the opcode and NIX BPE, you will be getting like this. And next what you need to find is the displacement. So here displacement, here we are considering the program block concept, in which 1 indicates the C data block and 0 indicates the default block. 1 indicates C data and 0 indicates default. Why C data? Here we have used a statement called as C data, and then it started with the address. It started with some new address will be assigned, and a block number will be given as 1. Okay, so in default section, some variable is being used in the operand field that is defined in some other block. Okay, but entire thing will be in the single unit, acting as different blocks. So how address can be, or the displacement field can be calculated? So for that, consider the current address of, that is when it is executing in the instruction first STL-RT-ADR, it will be its address is 000. So after fetching the instruction, what is the PC value? The PC value will be, or the LOC-CTR value will be 0003, because after fetching the instruction from memory, it increments by 3, that is the size of the instruction. And now to the target address. Target address is it is in the C data block, and its address also, it is starting from 0, that is the RET ADR. Okay, RET ADR is having a starting address in 000. So the size of the default section, here it is given that the default section size is default block size is 0066. So what is the address of the actual address of RET ADR? So RET ADR will be like 000 plus 0066, which will be equal to 0066. Okay, at RET, so the target address will be equal to 0066. That is the address of RET ADR. Now, in order to find the displacement, what you need to compute? You need to compute the target address minus current LOC-CTR value. Target address minus the current LOC-CTR value. The current LOC-CTR value is 0063. Okay, sorry, not 0063, 0003, 03, which will be equal to, what is the value we'll be getting? 66 minus 3. 66 minus 3, you will be getting 63. So this is the answer. That is, displacement field will be written as 063. 3 bits for the 3 bits will be used, that is for the 3 bytes, 15 bits will be, 12 bits will be used for the displacement field. Okay, so now grouping the bits together, you will be getting 1, then zeros 1 1 1, you will be getting as 7, then again 2, then the remaining displacement field you will be getting as 0 6 3. Okay, so this is the answer. So moving on to the next question, the feature of assembler which creates several independent parts of the object program, it will be called as the control section. So feature of assembler which allows a instructions and data to appear in a different order from the source statements. So it will be instructions and data appear in different order. It will not be grouped together. It will be divided into some parts and will be stored in specific area that is called as the program blocks. Then assembler directive which indicates the start of new control section, that is csect. Similar program blocks we make use of and for assembler we make use for the control section csect. Then what is the difference between control section and program blocks? So as we have seen in the previous questions, program blocks are segments of code that are rearranged within a single program unit. And in case of control section, they are translated into some independent object program units. So how it is being converted to the object code for this program blocks and control section, it is varying. How it is managed in the memory, that varies. So those are some of the differences that need to be included. Then how to in order to compute the object code for some instructions in this given program. So it from the usage itself we can understand that since here we are making use of csect, it makes use of control section concept. Okay, so control sections are there which will be acting as independent object program units. So here we need to construct the object program for this LDT maxlen. Okay, so in order to compute the object code of LDT maxlen, similarly in previous case what you have done, same way you need to compute the opcode NIXBP displacement thing you need to find out. So LDT opcode value is 774. So how you can write 0111, that indicates 7, and then 74. 4 means 0100. Since it is 6 bits, you can stop here 01. Then related to NIXBP, symbol addressing mode. So 11. B, base related X will be equal to 0. B also 0. P1. E, format 3 instructions. So E also will be equal to 0. Now you need to find the displacement. So in order to find the displacement, you need to understand the operand address, target operand address. So here max length is the operand variable. So max length, it is defined in the same control section itself. So okay, it is defined in the same control section itself. So the target address will be like the address of max length, that is 0028 minus current LOCCTR value will be 0006 plus 3, that is LDT will be taking 3 byte instruction plus 3, it is 9, 0009, resulting in the value 00028, that is while subtracting it becomes 1, borrowing you need to 16 will be borrowed since it's a hexadecimal subtraction. Then 16 plus 8 minus 24 you need to calculate. 16 plus 8 minus 24. 16 plus 8, 24 minus 9. Okay, 16 plus 8, 24. 24 minus 9, you will be getting the value as 15. Hexadecimal for this 15 will be F. So the final answer will be 001F. Okay. So in displacement field, you need to write it as 12 bits. So 01F you need to write. Okay. Then grouping together, you will be getting the answer as 0111 7. Then 01111 again 7, again 0010 2, and finally 01 F. Okay, so here we have grouped these bits in 4 bits. You are grouping those bits and you will be getting the result as 77201F. So similar is the case for the next question, that is here in this LDT maxlen. In maxlen is defined in the same program, and next is related to exit plus STX length. So in this case, length is the operand address and it is not defined in the same control section. It is defined elsewhere. It is defined in different control section. So how you understood that? That is, this length is given as an external reference symbol, which means that currently the object address or the target address will be treated to be as 0. Okay, for this length, the current target address will be treated to be as displacement or target address. It will not be taken because it will be acting as an independent unit, and we make use of the modification record in order to modify the object code for this format for instruction. Okay, here plus indicates the format for instruction. So while writing this instruction, again considering the considering this program again, for STX the code is 10. So NIX opcode field will be 001 00. Then N and I will be 11. X is not there, 0. B equals 0. P will be equal to 0 because E is 1. Then the displacement field will be taken as 20 bits. Okay, everything will be 0. So grouping the bits together, you will be getting 1, then 3, then 1, then followed with 5 number of zeros. Okay, this is the answer. 131 followed with 5 number of zeros. And next last one is like in order to get the maxlen object code for this maxlen word buffen minus buffer. So word is a directive in which you won't be generating any object code. But since here an expression is being used, it will generate an object code. But here buffen minus buffer, they are treated to be as external reference symbols. So since it is given in the external reference symbol, the object code generated will be 0. Okay. So object code generated will be 0, 0, 0, 0, 0, 0. That 6 bits will be taken to be as 0. So this is the thing you need to understand. Then different types of one-pass assembler produces object code for the later execution, produces object code for immediate execution. Features of load and go assembler produces object code for later execution, can have one-pass assembler. It is a type of one-pass assembler and also produces object code for immediate execution. Then data structure that is used to store the name and address of each external symbol is stab. Variable that indicates the beginning address where link program to be loaded is program address, PROGADR, and variable that is used to assign starting address to control section, CSADDR. Steps performed in pass 1 for linking loader, record type equals E, add CSLDH to CSADDR. From the algorithm itself, we will be getting this. Similarly, if passed to algorithm, if not end of input, address is specified in the end record, then step is performed as EXEC ADDR is equal to CS ADDR plus specified address. during pass-through of linking load algorithm, if it is not end of input, if no address is specified in the end record, then step performed is CS-ADDR is equal to CS-ADDR plus CS-LTH. Here